Welcome back. Let's take a look at a couple of theorems that are true for isosceles triangles. And let's see if we can back them up using some of the tools that we've picked up along the way. This is an isosceles triangle. It's got two congruent sides. That's all we know about isosceles triangles, is that they have two congruent sides. So this is congruent to that. That's all we know. What I'm curious about is it also looks like those are congruent. And we have ways to measure that, right? Like we have this tool that we can use to measure how big those angles are, right? Like we can measure, we can make a swoopy, and we can make a swoopy, and we can ask ourselves, how big is this opening? Is the opening about that big on this side? Well, it turns out, maybe. Is the opening about that big? Yes. Cross is right there. Yes. So using our measuring tool, the compass, we can verify that those two angles have the same measure. We can use a protractor, do the same thing, but our compass is our measuring tool, and so we can measure, yes, these are congruent. Why does that make sense? Well, it appears that there's a relationship between how long the sides are and whether or not angles have measures that are near each other or not. And it turns out that if these two sides are congruent, then their opposite angles must also be congruent. We can confirm that with a compass. Well, while we're confirming things, let's do the other thing that we practiced. Oh, can I? Yes, I can. Let's do the other thing that we, in theory, practiced. Let's do a perpendicular bisector thing. So if we do a perpendicular bisector thing, let's do the perpendicular bisector of the base. Let's find the midpoint of the base. And this is literally what we did in the previous screencast, right? So the question becomes, what does that line look like? Well, that line, if you draw it just right, goes through here, goes through here, goes through there. Are we surprised by that result? Well, no, we're not at all surprised by that result. Because what do we know about isosceles triangles? We know that this segment's congruent to that one. We now know that this angle's congruent to that one, and the purple fishy football thing creates a midpoint here, so this is congruent to that. And that means that triangle on the left is congruent to triangle on the right by side, angle, side. And so if all we have is the midpoint and we draw this down, if we don't know anything more, then this is the midpoint. Then the triangle on the left is congruent to the triangle on the right. And if the triangle on the left is congruent to the triangle on the right, then this angle and that angle have to be congruent. And if they are congruent and they lie on a straight line, then they both have to be 90 degrees, which makes sense because we were told that this is the perpendicular bisector. So all of the pieces are coming together to confirm that if we draw the perpendicular bisector to the side opposite the vertex angle to the base of an isosceles triangle, if we draw the perpendicular bisector to the base of an isosceles triangle, we result in two triangles that are congruent to each other by side angle side. So that's an interesting thing to think about and a pretty cool application of perpendicular bisectors that gives us some insight into how isosceles triangles are built, what their properties are, how we can look at them and break them down. Okay, so we're good here. Looking forward to seeing you when we gather in class.